So for this information session, again, I plan to spend, maybe 20 minutes going through some slides. I don't want to, do that too long because I want to have time for questions and hear from you all about what questions you may have about the program. I know that there are a lot of programs, data science out there, so I want to highlight in particular what is different about our program and how it's unique in many ways, and how it can position you for success in a data science career. So thank you everybody for joining. So just by way of introduction, my name is Paul Speaker. Um, my background is so it's just my academic background is I have a PhD in applied mathematics. My be That was quite a while ago. I was out of academia for a while. I worked as a data scientist for 12 years in industry, doing a wide array of different types of data science problems. And I've been able to see how data science has evolved over that time. And that's been kind of exciting for that. And that's what I'm looking to impart for you in our program. I've been the director of the program for the last several years, and so I'm happy to talk to you all about what the program is and what it can offer you for that. So in terms of the kind of overall plan for our schedule, talk a little bit about what is data science and how it's evolving, about Michigan State University, why it's a great place. Talk a little bit about the description, of our program in particular, and highlight its unique offerings. And then talk a little bit about the application process, because I think that's an important part of all of this. Um, so if again, if you have any questions, feel free to put them in the chat. I will get to them when I can. Um, if you want to wait till the end, that's fine too. For that. Okay, so what is data science? So data science is a lot of things, a lot of individual parts, but it's definitely a place where the sum is greater than the sum of the parts for this. So there are a lot of things that go into data science and making a worthwhile career. So there's statistics, there's modeling, and what modeling is a lot of different things. There's coding, um, there is data analysis, and there's also subject matter expertise. But it's not just these individual skills, it's the ability to put all of these skills together to make um, a successful project and create value for whatever you're doing for this. What of course, a lot of things are changing, and in particular, of course, everything that's going on with LLMs and AI is changing. So, what you see with LLMs is that they can automate a lot of steps individually. Um, but that doesn't mean the data scientist career is obsolete by any means, or coding career, or anything is that. What it places a premium on is, can you integrate the whole process together, working with other people, and create, and drive something to a successful conclusion, and make sure that it's working on an ongoing basis. That's where the real value is in data science right now. It's not just doing, this task, this task. Tasks are no longer siloed like that. That's where things are changing in this overall picture. I think that a lot of Education is very slow to catch up to this reality. And I think that we've done a good job of doing that. And that's that's where I'm going to highlight, what we're doing, what we're doing differently, for this. Okay. So, what is what do we want what does the program do? What does that allow you to do? So, what allows you to hit the ground running in the data science career, whatever that may be. You can work and not just on individual tasks, but truly work end to end to on the entirety of a data science project and be able to put it all together. Every, data is very different from project to project. Clean data is very simple. It's very easy. Data scientists don't work with that. We work with dirty data, and that's what we aim to make you comfortable in doing. It's being able to work on coding skills. But again, coding skills is not enough in the world of LLMs. It is being able to put it all together and ask the right questions so that you get the right project. The project is done right the first time from that. Similarly, you have the statistical and mathematical expertise to evaluate solutions, making sure that things work the way they should, for that. That's really what the main goals of the program are for this. Now, why Michigan State University? So again, our program is more rigorous than most data science masters in data science programs, and I'll talk a little bit about what that means in terms of expectations when we talk about the application process. But it's an interdisciplinary approach that unites the best of statistics, computer science, and computational mathematics. We're not sitting within one department or the other. We have three different departments that collaborate to give you the best education for this. It's geared towards the solving of real world problems in industry, not just textbook problems. It's not just because textbook problems now, if that's all you can do, you're just designing your career to be replaced by an LLM. For that, it's really is about putting it all together. And finally, MSU is a great place. Michigan State University is a great place. It's one of the largest and most diverse universities in the world. It's a beautiful campus. And because it's a large school, we have the flexibility to have elective course offerings to meet any need that you may have for your career for that. I'll talk more about that in a little bit, but that's something I think it's important to um, keep in mind for it. So in terms of the structure of what we have here, because it's more in depth, it's a longer program than a lot of programs. It's 4 semesters for a full-time student. We do have part-time students, but most of our students are full-time. And so that allows you to both get the technical depth that you need while as well getting the elective so you get the fully rounded education so you get the full picture of what that looks like. We've had some students finish in 1.5 years with it, including classes in the summer. It's not very common, but it does it is a possibility for some students, depending on what you want to take. In terms of the program cost, it's very competitive with most programs out there. We say it's 39,000, but that's not like it's per semester. That is the entire cost of the program. For people, that do the typical course work of 4 semesters, 1/4 of that Tuition is charged per semester, so it's 9,750 per semester for 4 semesters, which again is very competitive with most programs out there. On a per semester basis, it's lower than the vast majority of programs that are out there. If for part-time students, we do some different fee structures, but we have that option available. So let me talk a little bit about the courses that we have in terms of the rigor and the depth. So we have basically um, everybody has to take 30 credits, which is 10 3-credit courses. Um, Everybody does um, 6 required courses, which I have listed here. These 6 required courses are give you kind of the broad technical depth that you need to be a fully functioning data scientist. And then there's a 7th course I'll talk about in a little bit, which can look very different from person to person. Um, but then there's time for electives. And I say that everybody has to take 30 credits. You can take up to 36 credits without any cost. Um, Additional cost for that. So there's a lot of additional time you can spend taking electives that can match what you're fundamentally interested in for your program on that. So I think that there's a lot of interesting things that you can do with that. So with these 6 required courses, I'm not going to go through all of them, but again, it's a union of statistics, mathematics. CMSE stands for computational maths, science, and science engineering. CSE is computer science engineering, and then STT is statistics and probability. So you get the thorough understanding of probability and statistics. Um, you get a thorough understanding of, how to work with data, all these different kind of modeling techniques, not just at a superficial level that you can just run this package once and say, I learn it. You can create it from scratch. Because one thing we see with data scientists is that it's not enough to be able to run um, a package in Python like scikit-learn and call yourself a data scientist. You need to be able to understand the inputs and outputs. And a lot of data scientists have to um, not just use packages, but program it from first principles. And you get that in these courses that we have here. Um, which again, I think is a distinguishing feature of the program. All the courses are computationally focused. The courses typically, depending on the course, we do Python and R. We have found that um, it's not required that it's certainly not required that you know both Python and R coming on. A lot of students don't have exposure to one of the languages. But we found that it's there's aside from the strengths and weaknesses of different computer languages, it's useful to look at work in two different languages for your experience with the courses with the um, knowledge of what we're doing in this. So I think that's something that's very useful for all of that. And these courses allow you to set you up to be able to do that. Now, in addition to um, the required courses, again, there's a very wide range of electives that we teach. We have. We are we've had people take electives in almost 20 different departments. And we're very flexible about this because we want the degree to fit what you want to do. That's what's really important for the program for that. So this is just a sampling of some of the electives. I'm going to talk about the MLOps one in a little bit later. But the other one, like natural language processing, that's NLP. These advanced AI tech, methods, advanced machine learning, deep learning, Bayesian machine learning. You do courses on time series analysis, pattern recognition, and then there are ones that if you want to do like a specific, you want to do data science for a specific application, you could take electives in those applications. So we have people doing supply chain. Supply chain data science is a very hot area right now. It's very challenging. Economics, environmental science. People do quantitative finance. We've had people do biostatistics, genomics, just a very, very wide variety of different courses with that. Like I said, with the flexibility we have the flexibility to to take 3 to 5 electives over the course of the program. Most of those are second year, but usually have time to take one the first year also with that. And then the last required course is a capstone course. So the capstone course is a project-based course where it's group-based and it's an independent project with an outside client. So it's a real-world problem. So, which are always messy. We don't make it nice and clean for you to be able to work on it. We want you to be able to drive it to a successful conclusion um, for that. So here are just some of the names of companies that we worked with. We worked with Siemens, Caterpillar, Kellogg's, worked with many other companies with that. And so what the project is defined not by doing this method, but it's by ultimately creating value for clients. And it gives you the real world experience of what real data science looks like. So just some examples of what these have looked like. Um, for that we've had supply chain uh, and supply chain data science problems where we are trying to predict problems in logistics, problems in inventory, that all of that kind of thing. Um, we also do a lot of work with natural language processing and LLM. So we have a project right now with a retailer where the students are using natural language processing and LLMs to automatically generate a product description just based off an image. And having being able to do that in an automated way has been a very challenging, but it's turned out to be a very, very successful program. We have another one where we're working with a company that evaluates venture capital startups and predicts likelihood of success with the startups with that. So we have some financial modeling as well. Just a wide variety of different types of ones. We've had ones where we're using sensor data to predict defects in products, or looking at optimal solutions to different problems with that. So you have all of these skills to be able to do these kind of problems for that. Now let me talk about the MLOps course because this is I said a lot of things are unique. I probably overused the term, but this is a course where I've really seen what we're doing is a very, very unique offering for that. MLOps, so that stands for machine learning operations. So machine learning operations is basically everything a data scientist does when they're not building a model. You take all these courses. I build this predictive model. I build this natural language processing model, and you say that's it. That's what I'm done with. Um, but there's a lot, that's not even a majority of what most data scientists do. So what do most data scientists do? They do project planning, they do communication and negotiation with stakeholders to design the project. So most projects you're not even handed what you're trying to predict, what you're supposed to predict. You have to figure out what to predict for that. The productionization of model and model monitoring. It's all about process methods and tools. To the extent that MLOps courses exist, they focus almost exclusively on the tools part. So you'll learn about Kubernetes, MLflow, um, Airflow, these other tools which are great, which is important, but you don't get the whole view for what that has. So they're all the skills about design, making sure that the project works on time and is going to be successful and robust going forward with that. Model monitoring is a huge part of this because most tools don't do much with monitoring models, unfortunately. So this is a unique offering. This is a course that an increasing number of our it's an elective, but it's an increasing number of the data sci that increasing number of data scientists take. Um, I just heard from a graduate who took the course last year, who said that there were, he basically um, got, this was some of the skills he learned there were things he couldn't, he didn't see anywhere else and were directly applicable to problems in his job. And so that's exciting that we're able to meet the need for that. And I think that there's a lot we can do along those lines with that. So I think it's an exciting thing that we have. Okay. So what comes next? So we have a link on our webpage to placement information. But one thing I'll say is that we see people go into a wide variety of different jobs because the degree trains you for the kind of job that you want to do. Whatever that is. We make it work so it works for you. So majority people go into private sector jobs. So data science for financial firms, manufacturing. So financial firms. What financial firms? So we just had somebody placed at Goldman Sachs. We have a couple people working at financial firms at in Silicon Valley with that. We have people working in the manufacturing regime. And that can be a lot of different things. That could be with supply chain. It often is with supply chain, but it could be core manufacturing as well, manufacturing processes. We have people working in healthcare. We have partnerships with a couple of large medical providers in the area where we can connect people to the kinds of work that they can do that they're interested in. And you have people that go straight to tech firms also. We have people that also go to public sector jobs that could be in governmental positions or non-governmental or like nonprofits basically. So we have let's see we have one student that works for a nonprofit in Europe where she looks at solutions, you applying data science for global agricultural supply chain questions to to prevent famines, that kind of thing. So again, you have a wide variety of different things. And then we also do have people that if you want to go even more technical, they go into PhD programs. And we've had people go into several different kinds of fields for this kind of thing. So we've had people, for example, go into PhD programs in computer science or PhD programs in AI. We've had people go into um, you know, genomic, biological applications of statistics like genomics or biostatistics. We've had people go into PhD in economics, just a wide variety of different kinds of problems for that. And I think that's going to, probably the single biggest one is where they go. The biggest bucket of that is people going to computer science PhD programs where they're doing research into AI. But that's certainly not limited for what all is there. So there are, again, a lot of different opportunities that we have for all this. So this is just, some examples of, course plans. So if you're interested in, you have an idea about what kind of data science application you want to do, you can integrate that with what I call data science plus X. So you have a whole bunch of different, I'm not going to go through this, but you can see the different electives that you have. But this is the typical course schedule. So again, first year for whatever you're doing, mostly it's a required course, and then second year it's mostly electives. I have some things here that are not electives, but you have that are electives, but they're kind of fit what they have. If you want to do, machine learning for AI purposes, for doing, ML work, we have different tracks for for that, and we could fit into what you want to do again for the kind of program we have. Okay. So let me talk a little bit about admissions here at the end. We went a little bit longer, but this won't take too long. So, what are we looking for? We're looking for because we're more technical than most. We are looking for a quantitative and computational background. First of all, so what does that mean? That's kind of vague. So we expect to we expect people to have at least some coding background. It doesn't have to be hugely extensive, but we want to see at least a little bit in that direction. Now, our experience, from what I've seen, I'd say Python is the most common language that people come in with. It's not required for that. We have people that come in with R. We have people that come in with C. There are a lot of different languages. More languages is typically better for that. Now, what about quantitative background? Now, this is a little bit more flexible. We do typically expect people to at least have some calculus. Um, but beyond that, there, we hope to have more. There are courses that are helpful but not required. So having multivariable calculus is helpful but not required. Having linear algebra is helpful but not required. Having probability and statistics is helpful but not required. But we're not checking boxes. We're trying to find kind of a holistic one, a holistic background where if you don't have this, are you showing you have the seriousness to do this kind of work for data science? And a lot of this can come in this other bullet point, career focus. So career focus is, we want to see evidence that you have an idea about what you want to do. I mean, you don't have to have a specific idea, but you you're showing that you're thinking about what your career is going to look like, is basically what we're looking for that. Um, I'll talk a little about student demographics in a minute, but that's what we're looking at. So in terms of submission requirements, so we expect everybody to turn in a resume. There is an essay that's what we will call a personal statement. A personal statement is basically a description. This is who I am. So it should be very personalized that way. And this is what I want to do. This is why I want to do data science, that kind of thing. So typically, the personal statements are they're usually longer than a page, but not, up to 2 pages. So maybe a little over a page to 2 pages is typical. I'm not saying it has to be that way, but that's what we've seen. For most. We do require three letters of recommendation. They don't have to be from professors. If you've worked with people, that's helpful. And if that's generally a good thing to have. We don't require a GRE. If you do want us to consider a GRE, you can submit it and we'll consider it. But we're test optional for that. For most international applicants, there is an English language test required. If you go to the admissions website, there are some links for what scores are required on that. So yeah, you start the application at the just admissions.msu.edu. Um, we have what we call a priority deadline of January 15th. And what that means is that if you apply for January 15th, we will fully consider your application, and without regard to anybody else that's admitted or whatnot like that. If you submit after January 15th, it's going to be, we'll look at it, but it'll be looking at a rolling basis. We don't accept any applications. At some point later, we would cut off applications for that. One thing that we've seen um, with this is that for especially for international students, there's a higher priority to start the admission process earlier, and so that's what we do. And that so typically, if you follow this schedule, you will hear from us before any other school for this. So all applications will receive a decision within 30 days of submission. So if you submit, and I say not earlier than January 15th, which may be a little confusing. So let's say if you submit before December 16th, you will get a decision by January 15th for that. If you submit after December 16th, you'll get a decision within 30 days. With that. We will, and that's the commitment we have because the realities of admissions, particularly for international students, just requires this schedule for making it work for students. For that. We need to get things started as quickly as possible. So that's why we're on the schedule that we say we are with that. So overall, that's what the admission process is for that. Um, we have this link here, which is a link to our program. If you have questions that you want to email, it's msds.info@msu.edu with that. So that's what the program is. I think I'm very excited about the program. I think it offers a lot of things to students, and I think we've been able to build a unique program, which is definitely a unique thing. Oh, I was going to talk about student demographics. So our program, we have about so it's a 2-year program. Each cohort has about between 40 to 50 students. So, with 2 years, two cohorts at a time, right now we have about 90 students in the program. Um, with that, and we expect to be, so that gives you an idea about the size. Most of our students are international. Maybe two-thirds of the international. We have people from 20 different countries, over 20 different countries now. Um, and so it's a very diverse mix. I would say the student population is about half and half between students that are coming straight from undergrad or um, just been out for just a short period versus people that have been working longer. Maybe a little bit more than half with that, but we take people with that. We don't have a work requirement for that. That's basically what this that's basically what the student population is for that. So that's all I have for the presentation. Thank you for your time. And I will see if there are any questions that people would like to ask for that. You could put that questions in the chat for that.